Hi there, I'm Devish and this is my final project for ECE5831. I'll be presenting a short overview, then walking through the notebook and a Power BI dashboard I developed for this project. Pell eligibility is a common proxy for financial need, but it's typically only known after FAFSA is processed. A FAFSA is what a student submits to qualify for financial aid and loans. So from a pattern recognition perspective, this becomes a binary classification problem. Because real admissions data can be shared, I used a synthetic dataset that mirrors realistic structure. I also compared a logistic regression baseline to a simple neural network to evaluate its performance. Both models achieve very similar accuracy. The logistic regression model slightly outperforms the neural network in terms of ROC. This was very informative. It shows that added model complexity doesn't always lead to a better performance. I'll now walk through the notebook to show how the data is generated, how the models are trained, and how the results are evaluated. Then I'll briefly show a Power BI dashboard which I developed for the staff, which can be used for exploratory analysis. With that, let's get over to the Anaconda Jupyter Notebook. So what you see here is the structure of how this project is created. The first folder here shows the dataset that was generated. Then there are some figures that I generated within the notebook so that I can use those charts within the report for this project. Then there's a presentation which we were just looking at, and then there is the final report, and then the notebook and the README file. So with that, let's take a look at the final project. So this notebook right here generates the synthetic datasets, trains both models, and evaluates performance. All results in the report that I had submitted comes directly from this notebook. So first and foremost, let's take a look at how we are generating the synthetic dataset in this project. Like I mentioned, the real admissions data can be shared, so I generated a synthetic dataset with a very realistic structure. Features include academic indicators, geographical context, and socioeconomic proxies. Pell eligibility is generated using a nonlinear latent function to create realistic overlap. Let's take a look at how our dataset looks like. Here you can see the dataset has multiple columns. There is GPA, which is really important. Then there are SAT scores, school quality, if a school was rural or not, and when I say school, we mean high school, distance to the college, median zip income, students' first generation status, which is if they were first in their family to attend the school, and then lastly, but most importantly, the Pell eligibility of the student. This is going to be our target variable for prediction. Below, I did some exploratory analysis to take a look at the data set that was generated. So you'll see two charts below. One shows the distribution of median zip income. It shows a nice bell curve. And then there is a box plot of GPA by Pell eligibility. I then save the dataset that was generated so that we can use that in our model training. So I start with the logistic regression as a baseline, which is common in education analytics. For a lot of analytics we do at the university, logistic regression is a very helpful model. One of the examples in the past in which I've used this is when we wanted to predict if an admitted student would ultimately enroll at the university or not. A logistic regression model was very helpful in being able to predict that. So, a logistic regression model establishes a reference point before introducing a neural network. The baseline performs reasonably well in this model. We achieved an accuracy of 92.5%, and we also have a decent ROC AUC over here. We are then plotting the ROC curve, and then it's also being saved in the directory as we uh, saw before in the folders. Moving on, we now build a neural network model. This is a simple multi-layer perceptron with two hidden layers. The architecture is intentionally kept small to avoid overfitting, and you'll see below that the training converges pretty quickly due to dataset size and model simplicity. Here we define the model. As you see here, like I mentioned, the model converges fairly quickly. And as you'll see here, the ROC curve shows that logistic regression slightly outperforms the neural network in ranking. Both the models have similar accuracy, which suggests that the dominant signal in the dataset is largely linear. So down below is just a comparison of both the accuracy and the AUC of both logistic regression and the MLP. With that, let's move over to the Power BI dashboard that I developed using real data. So what you see in front of you is a dashboard that's created in Power BI using real data over a couple of years, all the way from 2022 to 2025. For obvious reasons, I have put in some filters in this to maintain privacy of the data so that this doesn't actually show real data. So to orient you to the dashboard, there are some filters on the top which can be selected to filter the whole dashboard. And then you'll see below there's two charts. One shows percent Pell by the aid year, and then the Pell count by the aid year. So this shows the overall percentage. And then here it shows the count. as it's obvious that a lot of times um, percentages can be deceiving, as we might have a very high percent, but in terms of count, it's very low. So to make sure that we make an informed decision, both the charts are being showed. This is very helpful to the staff as it serves as a self-service tool in which they can go in, select multiple filters, and then see if a particular filter affects and influences the Pell eligibility overall. For instance, even in our dataset that was generated, the first generation status is usually a very good indicator whether a student is Pell eligible or not. So with this data, the admission staff can go in and select filters to figure out if a particular variable influences the Pell eligibility. So this is the kind of visualization that could support institutional analytics. And with this data set, um, using a combination of filters can also suggest that um, combining multiple factors together, we could narrow down and be able to predict the Pell eligibility of a student. Of course, there is no predictive analytics in this dashboard. However, it serves as a very good tool for the staff to understand the historical data and how some of the variables affect the Pell eligibility of a student. With that, let's wrap up this presentation and go back to our slide. So in summary, this project demonstrates a complete pattern recognition workflow. The main takeaway for me was the importance of baseline and transparency, as a lot of times we don't need to create complex models. Sometimes simpler models can be good enough to make predictions. So it's always important to compare and contrast multiple models and see how they perform. For the next steps, the future work would involve using real data under privacy controls and even more richer features. With that, I'll conclude the presentation. Thanks so much for listening.